Okay, hello everyone. Welcome to another software design discussion, part of our incremental language development series about future versions of Wolfram language. And I think first up, minimal tree design. Oh, wow. Okay, do I run this code or not?
You don't need to run the code, but if you'd like to play with the examples, you can run the code to play with it.
Okay, so we've got lots of things going on here. Okay, that looks pretty nice. That's a random tree without labels.
Yep. I believe, and Ian, you can correct me if I'm wrong here, but the specific bit we're looking at here is the unlabeled tree design.
Ian?
If you're talking, we can't hear you.
We need Ian for this. So if Ian is somehow, we should go on to the next item and come back to this.
Okay, yeah, we can start talking about the next item, and then whenever Ian's here, we can look at it.
Can somebody message him, please, so we get him?
Yes, I'll message him.
He is here, but he must be having audio.
Can you hear me?
Okay, now we can hear you.
Sorry.
Okay. All right, explain. So we're dealing with the unlabeled tree. We've got an unlabeled tree wrapper.
The literal function unlabeled tree. What should the output look like?
Okay, so what you're showing us here is what unlabeled tree wrapped around random tree of 12 should look like. Is that the point?
Yeah.
Okay. And so those node sizes, we have some method for dealing with absolute versus non-node sizes in ordinary graphs. I mean, I would assume this should look the same, albeit with different colors. I mean, if I do this as a graph, right? So I say random tree 15 or something, and then I say tree graph of this. Okay, so the differences here are you've got gray as opposed to blue. Yeah, well, we're comparing these two things, right? Is that correct?
I suppose.
Well, how could it not be? I mean, you know, we've worked on the design of graphs. So now we want something for the design of trees. I mean, what am I missing here? I mean, in this case, we have much thinner, narrower connections here because we are using the fact that the very placement of things in the tree is an important part of the information content. Is that correct?
I'm not sure. That's just a thickness of 1 from the original design spec.
It shouldn't be a thickness of 1 what?
Pixel, I think.
Well, that's no good. That won't work. If we print it, it will go away. 1 pixel, you cannot do that. Okay. Who's been paying attention to this?
Can you?
That doesn't work. Go ahead. What are you going to say?
Well, can you do tree graph of %? So we rather than reevaluating, and so we get a different.
Right. So those are much thicker lines. Okay, if that's 1 pixel, it is a bug.
So it's absolute thickness of 1,
which is 1 point. It's not 1 pixel.
It's not 1 pixel. Is that right? Do we think, Billy?
Well, I presume that's the spec, right? I mean, we got a spec from design, and which I presume is what.
Yeah, and this is an absolute thickness of some kind. So there is
the graphs are the same, right?
What do you mean?
Like graphs are yeah, right. If it's 1 pixel thick, it'll be the same with graphs and trees, right?
Well, it should be, but I don't know whether it doesn't look it. It
so
looks like
it's 3 pixels or something, 3 points or something, right? But I mean, it's the same idea.
Right, but does somebody know what it is for graphs?
Unless Charles is here, I don't think anybody knows what the default is graph, right? But of course, I mean, we don't, right? I mean, not that there shouldn't be similarities between trees and graphs, but
no,
like,
I know, it don't necessarily have to be identical.
Right. I mean, in fact, and the argument should be that by default they shouldn't be identical, right? So that you can tell them apart.
Yeah, I know. But things like the thickness of the lines is not the place where they should be non-identical unless there's a good reason for it. Could we see if we can reach? Do you think Charles is the right person to answer this question?
Charles would be the correct person to answer this question.
I mean, we could, in principle. Let me just see, just for the hell of it. Does that give us information, or does it not? Bezier curve, opacity 0.7. I think this is the default. I'm not seeing anything here that's setting line thickness. Well, let's see if we can we see if we can find Charles and ask him?
Yes.
Okay. Personally, I'm not wild about the hugeness of those nodes. Up here, I mean, I rather like the look of this tree. I'm not complaining about this. I'm just not super happy about its incompatibility with what we're doing with graphs. So what do other people think about that tree? I mean, the other thing we're doing here is those are solid blocks as opposed to what we're doing here, which is to have, a rim. Can somebody comment? Who was, sorry.
I think there is a rim there. It's just hard to tell.
Okay.
It's a little bit, it's a little bit thin, but maybe once we sync up the two thicknesses of the edges, we'll be able to see it a little bit better.
If that's inheriting the edge thickness for the rim.
Yeah.
But we better figure out, I mean, is this do you believe this is the same size as for graphs?
Yeah, I wasn't sure either when I was listening.
Well, okay, so we got to figure that out. I mean, same size of the nodes being the same size. I mean, I don't mind the look of this. I think this looks pretty decent. Actually, in some ways, it looks better than what the graph looks like. Okay, but let's take a look at the other things you're. No, I don't think we should do that. Well, anybody else want to comment on that?
We kind of liked how it looked, like a little spindly.
Oh,
but
sorry, I was muted. I mean, right, there are several alternatives being presented here. So maybe rather than going into a detailed discussion, we should look at the survey and then.
Okay, fine. Well, these are all alternatives. They're not just different cases.
Correct.
Are those diamond things down below alternatives, or are they part of the same thing? I wasn't sure. So if you scroll down a little bit.
If I might comment, you've got
to understand the same alternative.
Okay.
Right. So this is keeping the distinction of shapes based on whether the children is none or a list, like we do.
What the heck is this?
So
what Ian just said, maybe you should listen to.
Yes. So in the labeled tree case, we distinguish between leaves and non-leaves by having square or rounded rectangles, right? And it has nothing to do with the label. That's strictly a property of the tree children. So there's an argument that unlabeled tree should also have different shapes for these things.
So
right.
hold on.
So
interior node, how can it be a leaf? Am I confused somehow? Only an exterior.
No. I'm saying you can have an exterior node that's not a leaf.
I see. Because it is not a leaf because it has no children, but it isn't a leaf node.
Yeah, if you have an empty list or an empty association.
Is that really a distinction that we make elsewhere? Like, does tree leaves not include those?
In 13.1, yeah.
I mean,
so this is what, like, if we just kind of project this to a graph and have all the same nodes,
then that will be this case here.
You're losing more information than just the labels, I guess.
Because those null non-leaves, the null children non-leaves.
The symbol none versus a list or an association.
Right, none is a genuine leaf.
Mm-hmm.
Huh.
So
I don't know. I mean,
wh-
maybe
why,
I'm just
why,
not, go ahead.
I'm sorry. I see, like at the very bottom, there's like a square, but above that, it's a. I guess I'm
This
not
has
clear.
to be wrong. This I just
No,
don't.
so
understand that.
squares can only be exterior nodes. But exterior nodes can also be circles or diamonds. Just like inner nodes.
What is a diamond?
An association. Right. So currently association and list are just both rounded rectangles. So this is an idea to split off association into a third shape.
I feel like
I think it's great.
associations, it
Yeah.
seems like associations, the thing to make a distinction on would be edges coming out of it as opposed to the node itself, right? Because it's basically like, I mean, correct me if I'm wrong, but I thought associations were for sort of labeled edges as opposed to unlabeled ones,
Yes.
as opposed to indexed edges.
Yes, that's correct. As opposed to positionally indexed edges.
That's correct.
So in other words, the part specification on a tree would have an association key as opposed to a positional number.
Yep.
Right. But it seems like then the thing to do would be to label the edge or to somehow annotate the edge coming out of that node.
So the default edge label is the key.
No, I understand, but what Christopher is
so
saying
it
is,
already does that. I see. So
Right,
it
but-
already labels the
Yeah, and just a minor point that's maybe not so important is, what if you have an empty association, then you don't have any edges coming out to style.
Yeah, sure. Yeah.
Right,
I feel
but the
like the
basic-
empty association case is probably, I mean, if the only case where it's actually ambiguous is when it's a sort of one of these empty non-leaves, then I think that's kind of an edge case.
so to speak.
Jose has suggested that it might be a good idea to have some sort of like partial stem coming out in such a case, but we haven't come up with the design for that.
I think it's an unusual case to have a childless non-leaf. And I agree that that's a nice notation for a childless non-leaf. Would be a little stub of a stem that doesn't go anywhere. Well,
Having something there kind of
no, because there's
feels
one
like
there's
there's
one of
something
it
there,
which
yeah.
seems wrong.
Mhm.
It's zero of it. I don't know. What do people think about the use case for the childless non-leaf?
It is essential, and it's the thing that allowed us to actually support things like XML in this version, because you can have a tag with no contents, and that's different from just text.
Right. I mean,
Right,
I'm not
that's
disagreeing,
the
but-
right. That's the F of bracket case,
Mhm.
right? I mean
Yeah.
that is an important.
Yeah, and
Case.
we were doing some clever hacks before in order to make expression tree work in those cases before.
I mean, otherwise, what you do is you just say that F open close is a whole leaf, right? Which that's not great, but
No.
it is doable.
Yeah, it's doable, and we did it, and now we have a much cleaner design with
Yeah.
this empty list.
All right. So conceptually, it has all of the tagging of being a head. It just doesn't happen to have any arguments.
Correct. It's a zero length head or zero length expression. Zero
I'm
argument
just not
expression.
wild about the squares as the endpoint. I don't know what makes it. There doesn't seem to be any endiness to a square. If that makes any sense.
Right. In a sense, it seems wrong, right? It seems, the fact that it seems on some level, it seems like the circle, sticking with these three symbols, it seems like the circle should be the leaf, given that the, circle and diamond both have children right now, right? So you'd think that the two things that have children should be more similar.
On the other hand, diamonds look more leaf-like.
Yeah. I guess that's.
Can you look at the labeled case where we have
maybe we need to use the
These are
clover
rectangles
the clover
generally.
character for the leaves.
Right.
What?
Get some bark texture on the edges.
Oh, I guess we don't have an actual I guess the cloverleaf character that we have is actually the command symbol, but
Hmm.
you know.
This doesn't look bad.
Right. So my
This
point
really
is,
doesn't look
like,
bad.
rounded rectangles correspond to the circles. It's just
Yeah.
if you have a label, it becomes a rounded rectangle instead of a circle. And so if we invert that, then we would have most of the thing being rectangles and then the leaves being rounded rectangles.
This is quite nice. So let's understand how we.
I personally think that the distinction between the rounded and square is important. The one that I'm not so sure is the diamond.
I think it's irrelevant. I don't think we should do that distinction.
Yeah, the diamond, I think perhaps it should be something that you can opt in with some string value somewhere, but not by default.
Yeah, I agree. Is this a different green? Did we go more camouflagey or something here?
It's to match the unlabeled version. So if you go and look at original down below, also, it's like much lighter before.
Yeah, which.
So this was to address the concern if instead of using unlabeled tree, you do like a tree map of null on the whole tree. It was way too faint.
Because why? So I'm confused by that. So
can you do like tree map null over a random tree?
No, ampersand.
Yep.
Yeah, it's pretty ghostly. Look, we got to find a way. I think this is too dark. Well, I don't know. What do other people think? I think having a default background is not great, because I can imagine all kinds of weird cases where you've got a color in that, in the node, and it looks really ugly with that background, and so on and so on and so on.
I think the green is a little bit is slightly, old school terminal looking, but
yeah, especially with the square characters. Okay,
something a little bit lighter back there.
Yeah, but what about the possibility of darkening the border when the things? I mean, in other words, if what we're trying to do, what about darkening the border but not darkening the interior?
Yeah, the only issue that might come up is those ABC on those connecting lines, if they get darker as well. But
if what get darker? If the connecting lines get darker.
Yeah.
Well, then why are those ABCs? Is that an edge label? Is that a graph edge label? Does it sit on top?
No, that's because there's an association there.
No, I know that, but I mean, in terms of when you have a graph label, an edge label in a graph, doesn't it sit to the side of the edge rather than on top
that's
of the
the default edge label placement.
This one here.
Mm-hmm.
Okay, well, so if that's working for ordinary graphs with that darkness level, and maybe it doesn't work well for that. And by the way, now that we have this kind of drop shadow technology, maybe we should be using that for a bunch more of these labels. Charles, do you have a comment on that? As the creator of both the labels and the drop shadow?
Yes, we are experimenting, and and we hope that when you reach there is a performance issue we are working on in terms of drop shadow, so you can have thousands of them in a page. But yes.
What is
there was, by the way, there was a question earlier about what line thickness are the edges using by default? Is that just a normal graph, whatever the default of graphics is?
That's what we want to know.
Yeah, that's the default line thickness.
Okay, maybe a little thick. But okay, we should do the same thing for trees. I can't see any argument for not doing the same thing for trees. But now you have a non-zero, you have a non-1 opacity for these, right?
Yes, if I I don't remember. We have opacity.
I just looked inside. It was like 0.7.
Yes, there is one. Yeah.
So I suspect that's what we should do for trees as well. Even though for trees, we know that there won't be the same kind of overlap issue as there is for graphs.
I mean, basically, visually, the trees are going to look more like graphs, but the only distinction is going to be, the shape of the vertices, I guess, and then the color.
Yeah, the color, the greeniness.
Also, when you click them, graph is purple, trees are green.
I know.
Sure. Yeah, and I guess also the edges don't have arrows in the. I mean, they don't always have arrows in the graph either, but yeah.
Right. So, and the fact that, I mean, I don't know whether we should be looking, because I'm not wild about the way that this graph looks here. It's certainly better than those crazy brown ones from a few versions ago, but it's possible that we should try and re-up this again as well. Comments? Charles, any comments?
Yes, I agree. It's something we have been considering actually, another pass of looking at the way graph look. I mean, we built that 10 years ago, right? I mean, things look, we can make it look better. Definitely.
We should do it. We should get a meeting with design about that. But then, okay, so for trees, I think we should try and follow graphs more closely. And if we, maybe trees will lead, because I personally, I like the look of these nodes better than I like the look of these nodes.
Well, I mean, it seems like, hold on. If we're gonna change the styling for graph, I mean, my guess looking at the current graph is that, is that probably the changes are going to be like make it a bit lighter weight, like bit lighter.
Yeah.
In which case, making trees a lot darker to match the current graph seems wrong.
Stupid. Yeah, right. Well, fine. Maybe trees should lead the way for a new look.
Another thing, just to mention, but at least for graphs, I don't know about trees, but at least for graphs, it seems like the default styling should probably also be, performance informed, because I think sometimes when you have really big graphs, it can be a problem.
Yep. Well, okay. What do you think? Do you think we should leave the absolute thickness 1 thing here, even though that's different from graphs? Comments from people. On the grounds that might be the future of graph itself. Nobody got an opinion?
I kind of think, I don't know. I don't have much of a problem with it being that thin. I think you can easily see it. I guess trees are a bit easier too, because the edges are in predictable places. Like you could basically not draw the edges and still know what's going on, which is not true for graphs.
Right. And I think I guess I like the trees thin. I'm not sure how much thinner we can make graphs, because with graphs you can also have curves, and you can have more interesting edges than you can with trees. Right. Okay, fine. Well then, okay, then let's assume we're okay with this. Do we think we're okay with this look for this random tree? So then if we move that down, so that means, is this the same thickness here with the labeled tree?
I think so.
Do we like the look of this? Again, we think we're going to have to go less ghostly for the nodes, because we've gone much less ghostly here. And then is this darker green here the one that matches that darkened look? No, it isn't. It's different. It looks different here. That is not the same as the unlabeled tree look, right?
Yeah.
So what are we doing here? If we have a labeled tree which happens to have unlabeled edges, do we want it to look different from the purely unlabeled tree?
I would argue they should look the same, because if the thing that's distinguishing trees from things like graphs is the color, then all trees should be that color by default.
Okay, so I think we can cheat greatly in terms of lightening up the background of these big ones and still keeping it dark in these small ones.
Mhm.
You're saying that if the tree happens to not have a label, that it will render the same as unlabeled tree by default?
That would be the suggestion, yes. Is there a problem with that?
I mean, so right now all of the nodes are using the same style, and I don't know how that behavior would interact with style
Here,
option.
you know what? We can't make that work, right? Because I'm telling you, you're going to have to cheat. For an unlabeled node, it's going to have a different styling than a labeled node. Just that's going to be necessary from a graphic design point of view. You can't make it work. It won't work. When you have a big area here, if you darken it to the point that you need to darken it to get one of these to work, it's going to look stupid. Get what I'm saying?
I mean, so what I'm saying is, like, if the unlabeled nodes are filled, what happens if you specify red for that node? Are you getting
It
some
makes it
darker
red.
red, or does it
Oh.
just become red?
Just becomes red. What happens in a graph? It's the same thing. You just overwrite it, don't you? Vertex style just overwrites.
Graph by default doesn't have two different colored nodes.
It doesn't matter. This is the generic, and anything you do overwrites this. That would be my point of view. If I color the nodes in a graph here, I get the whole node, including its border, right?
You can use
Is-
edge form to affect the border.
I know you can use edge form, but without edge form, the whole node just becomes red, right? Is that correct, Charles?
Except the
Yes.
edge form.
So here, if I say graph of that, comma, vertex style, one arrow red. Oh gosh, that's because what are the node names here? What the heck are the node names here?
They're like, just do blank.
Okay, so what happened there is, as you can see, the edge form did not by default get changed. Is that correct? The filling of the macaroon or whatever it is, I don't know what, got changed out, but the crust did not.
Mm-hmm.
Do you know what I'm saying? So we should have the same behavior for tree.
So I can't quite see, but is the edge just basically black or gray, or is it actually blue on the graphs?
I'm not sure. Does anybody know? Let's see. We can just make this. It's absolute thickness, isn't it? No. So there.
It looks
that-
black.
So there is an edge form, which is gray level 0 says black with opacity.
with opacity.
Okay.
And
Yep.
so that's why we're seeing this not coming out as black. So it's black, but with opacity.
I think that's the right thing to do, though, because it just means that, if it's black, it's not going to be much of a problem. If you set the vertex color to something weird, it'll
Yeah, I
pretty much
agree.
always look fine.
I agree. So I think we should emulate that for trees. So one possibility is to go with, I don't know what this edge color is here, to go with black at a lowish opacity. Making sense?
Yep.
Okay, so what are we doing here? So we got to solve the technical problem of, I mean, for this version, we could just say unlabeled trees do one thing and labeled trees with unlabeled nodes do a different thing. But what are we expecting there? This doesn't work. This isn't right.
So for the unlabeled tree case, are you fine with the colors from above? The filled nodes that are dark green?
I'm okay. I'm
And
not-
do we want the squares and circles?
Hmm.
I think we don't.
I think
we
for
agree
the
that we don't want the
unlabeled tree,
diamonds by default.
no, we don't want the diamonds. I think for the unlabeled tree, we should punt on the squares. That's what I think. I think you're rarely going to want it
Circles.
because the case, I'm sorry, everything is circles, yes. Okay. And then for the labeled tree case, because a lot of the labeled nodes have these rounded rect squares, I think we're good with squares. Okay. So the only thing that I see as a problem is this needs to be lighter, maybe not.
Should it just be the original?
Yeah, but it could have a darker border. I don't know whether what that will look like. But this has a thicker, that line is darker, which is probably good. And then that border, and then the light interior. Am I making sense? But then this, I think, should darken up a bit. Go even darker than this at the minimal size. Make sense?
Yeah.
Okay, can we try it? Or maybe we can wrap back to this later in this meeting. Make sense? Can we move on?
Okay.
Any further things on trees there?
No.
Okay. Disjoint, intersecting Q, subset Q, operator form.
Yep. So these are three functions we touched earlier in 13.1. We were in the process of documenting them, and we noticed they hadn't been reviewed. And specifically, there's a question about the operator form of subset Q, which argument should be in the operator form. Because with disjoint Q and intersecting Q, they're symmetrical. It doesn't matter if it's the first or second argument, but with subset Q, it obviously does matter.
Or do they even need the operator forms?
Danny, it's probably you. Sorry, say that again about, I mean, I'm a little bit, yeah, you're saying, why do they need operator forms?
That's what I just said. Yep.
Yeah. I think the operator forms are confusing because you're never going to know which argument is you're saying it doesn't matter, they might as well be curried, right? You're saying it just doesn't matter which order it is. It's as if currying.
Yeah, for disjoint Q and intersecting Q, it doesn't matter.
So wait, but hold on. Shouldn't intersecting Q be var args? I mean, maybe it isn't, but you might imagine it would be. And if it were, then there shouldn't be an operator form. It should just always return, I don't know, true.
I mean, these functions are not new in 13.1. I think the same test Q option being added and the operator forms being added are new. And
right, but we've only defined intersecting Q for
yeah.
two argument form.
Right.
But intersection is var args.
Right.
Right. And it seems useful for it to be var args. I think one day it could be var args, in which case we shouldn't give it an operator form.
Yeah, I agree.
What will it mean? Do they all intersect or do pairs intersect?
I think it's just checking if length of intersection is greater than 0.
Yes.
Okay, because although it's not on this list, it probably should be. We do have unique elements, which can be used to. Does that work?
Well,
yeah.
But does that give true or false, or is that just the same?
No, but it
intersection.
Right. Well, right. But intersection can also be used, right? I mean, why did we need intersecting Q to begin with? And the answer is Tali, is the short answer. But I mean, I agree. It's sort of useful. It's a somewhat useful idiom to say just intersecting Q rather than intersections, not the same Q, empty list. But
I'm just expressing doubt that we need to make it var arg. That's all. I'm not saying we absolutely can't, but I don't see
okay, well,
the
fair
reason.
Enough. But also this pairwise, I mean, it's like unsame Q, which is all distinct.
Yep.
Right.
But I should say these functions have had an operator form for several versions. It's just that we never documented them. And so there was a note in the documentation saying that intersecting Q should be var arg. And so it has to be one or the other. So that's a decision to make here.
I think we should do nothing. I think we should neither. I don't think we have a strong opinion either way. I think we should do nothing. I think we should neither make it var args nor make it give it an operator form.
Should we remove the operator form? Or just not document it?
I somewhat think we should remove it. Now, doesn't contains Q has an operator form?
Yes.
Wait, do you mean member queue?
Oh, member Q definitely has an operator form. Is it only string contains Q?
No, we have the whole 5 members
Well,
of the family.
there's contains any. I don't remember a contains Q.
Right,
but maybe
contains
there is.
any, contains all, contains only, contains exactly.
Okay.
Although in a sense, I feel like this is more obvious, right? It does, the operator form is does whatever I eat contain the thing that's contained in the operator form. Whereas subset Q, I think, is a bit more confusing.
Yeah. I don't
I
think
mean, maybe subset Q, maybe we can just think of it as, I mean, we have these contains functions that already have nice operator forms. Subset Q is identical to, what would it be, contains all or something like that, or contains only, or one of those. And so maybe subset Q should just be a more rigorous kind of takes two argument function.
I kind of think so. I don't think we should have these operator forms. Same test option, I don't have any problem with that. Seems like a good idea to me.
Okay, same test stays, operator forms go.
I think so.
Yep.
We have had them a while, but all right.
Well, I guess we'll find out if anybody's been using them.
True.
Yeah.
I would like to make a brief statement, which is Jose and I put in basic documentation, not just for delete elements, but also for unique elements and whatever the other one is.
Symmetric difference.
Yeah, you might want to review that just so that we can, we know for sure that it's green lit and can be put into the main release branch.
Unique. What's the difference? Unique elements. What's the difference between unique elements and delete duplicates?
Well, that is my first question as well. But I think it's like.
Oh, it's unique elements across multiple.
Yeah.
Things.
Find the ones that are unique to each list. Sub whatever.
This was at one point called all complements. So it's the complement of each list against the other lists.
Against,
that's
presume the union of the other lists.
Yeah.
I'm not wild about the name unique elements. I mean, this is.
I'm sorry. I did not ask you to revisit that.
Okay. All right.
Just the documentation.
Okay. The documentation.
That one was not on the table.
Which are not in any other list. Okay. Gives the elements for each. Okay. Fine. Okay.
Should it be unique elements list or each unique elements? I mean, I know Danny will kill me for opening that kind of.
Yeah, unique element list of sublists, inside lists.
But doesn't this only work at level 1? Isn't that part of the point?
I can't answer that. I haven't tried. I suppose elements could be lists.
Right, but it's still looking at them, right? Each element.
Yes, it is looking at element at level 1. Yes, and no, you cannot add a level spec.
How would people feel about a name like that? Lists unique elements. I just worry that unique elements plopped out of the blue. It's kind of an obscure name.
Maybe we should call it, list intersection or something. Oh, actually, maybe intersection.
No, it's not.
But I'm just saying, like there are tons of functions that operate on lists.
Oh, I see.
Start them all with list.
Well, fair enough. Christopher, what do you think about the name unique elements? Are you okay with it?
I think it seems fine. I mean, it seems similar to what are the other functions we have, like count. Wait, isn't it called count distinct, which is slightly different,
Yes.
but I can never remember the name count distinct anyway. Yeah.
I mean,
What
one
does
thing
count
is,
distinct do again?
if we think too hard about this, we're going to get back to all complements, which had already been rejected.
By the way, does
I'm being
anybody know?
serious.
It seems like we have so many.
I
we have
mean,
duplicates. We have distinct. We have unique. We have so many different terms for this concept. You know,
Well,
and
well,
I
I mean, there's-
right. Although I think that's a different issue from the fact that, you know, all the ones we have right now are sort of operating on one list, and right, you're giving me the distinct elements of this list, you're deleting the duplicates in this list. And this one is not acting on a list, it's acting on a list of lists.
Oh, that's true. Yeah, unique elements. Actually, no, that's I didn't realize that point. Unique elements sounds like it does what delete duplicates does.
Yes, right.
Right.
Which is why I'm suggesting lists, plural, unique elements.
So this is the discussion we had last time, in which we were considering whether this should be var arg, because, for example, symmetric elements, symmetric difference, is var arg. No.
Well, this one really can't be, though,
Well,
because I mean, it has that structure issue of
so
recapitulating the input structure.
So your argument is that it has the same input structure as output structure.
Yes.
It might be a little weird to give a you know, a sequence of arguments in and then get out an analogous.
Yeah, I agree. I think it's a
list of things
pruner.
out.
It's basically a pruner that prunes down to the single unique
Right.
element in each list.
Right.
Yes, but then that makes it have this additional level of list that makes it difficult to name.
Well, except I don't think that's. I disagree with that analysis, right? I think what makes it difficult to name is that it implicitly is that it has multiple lists in it, whether you pack them in a list or call it var arg, as opposed to the other things where we talk about unique elements in which you only have one list no matter how you look at it.
Right. Like counts and things like that.
Right.
What do people think about lists, unique elements?
It sounds very awkward.
Yeah, I mean, unique elements list sounds better to me. I'm not sure necessarily.
That's the wrong thing.
That two plurals is reminiscent of Johns Hopkins, which I think was also a mistake.
Why is it called that? Was there a person called John?
I assume it's his name.
A single person's name?
Yeah, I'm guessing.
Really? No. That
Maybe
would
it's two people.
Oh, it
It
is?
has to be two people.
Well, I don't know. I'm guessing, but who
Or
knows?
4 people, 2 of each. I don't know.
Do you know that?
So Johns Hopkins is a single individual whose first name is Johns and last name is Hopkins.
That was my guess.
Wow.
And
Well, there
He
you
was
have it.
apparently named
Yep.
after his great grandmother, Margaret Johns.
Ah,
Okay.
Yeah.
I was thinking there might be a ST in there somewhere originally, but which I won't even try to pronounce, not being of the right nationality.
But it almost makes me remember the trivia of Addison Wesley Publishing Company, where it was started by 2 unrelated people, both with the last name Cummings, and they used their middle names as the thing for the company. At least that's what I was told by their executives many years ago, long before the web existed and before you could check statements. Okay. In any case, back to this.
Yeah. I mean, I guess one question is the documentation with the usage, et cetera, okay, modulo possible name change?
Yes, I think the documentation is fine.
Okay.
Other
Why
than
don't
you need
we-
captions for those examples.
Sure. Yeah, no, the examples are not complete, but Jose and I wanted to be sure that we had the rest pinned down correctly before proceeding.
What is this thing really? This is those elements, you're pruning down to those elements
that don't appear in any other list, right? So each
Right.
list gets reduced to the things that only appear in it and no other lists.
Not like select unique.
No, because select usually has all kinds of stuff in it.
It's the same problem.
The original name was all complements. This could be multi-complement or something like that.
That's incomprehensible. I have to think about complement. Every time I use complement, I have to think, oh, we start with a universal set and then we subtract the other stuff. It always takes me, at least me, a moment to think through how that works. I mean, it's really what would people use this for? It's a pruner.
The case I always use it for is I'm updating the list of units that are in Wolfram language, and I want to know which ones appeared and which ones disappeared. And so I need to know which ones are unique to my starting list, and
I
which
see.
ones are unique to each revision.
It's sort of like the disjoint. I mean, I guess that's another thing we talked about last time, which is the disjoint, what's it called? Disjoint union, something like that. Yeah.
Yeah, that's the symmetric difference, I think, is the
Symmetric
Well,
difference. That's it.
You don't
Yeah.
want to get too much into that analogy
Yeah.
because of the in-out, even odd, whatever parity, which this
Yes.
does not have.
I use a function like
Right.
this.
In a sense, this is simpler than complements because all the lists are treated symmetrically, which is not the case of our complement function.
Correct.
Yeah, right.
Correct.
I mean, this is actually a useful function. I mean, in the what's new, what's old, what's coming in, what's going out. It's like the diffs.
Right. If you want to compare several lists, this is very useful because you know who is responsible for having too many elements or too few elements.
Well, maybe the name is okay.
Maybe we should just call it differences. Whoops.
We have that, don't we?
Yes, we do.
Thank you.
But it isn't really. All right, I'm not coming up with anything better. And this is probably what we went around last time. So let's assume we're at the best point. Can we make it experimental for this version, just in case we have a name disaster?
Yeah, we can certainly tag it as experimental.
Okay. Delete elements. What do we?
I'm sorry, we're just tagging it as experimental. We're not putting it in experimental context.
No,
Connor.
no, we're just tagging
Anything ghastly. Okay, fine.
No, nothing ghastly. It's absolutely lovely. Delete elements. What's the question here? Do we delete 1, 2, or 3 A's? What is the specification of delete elements here?
Yeah, so there's a multiplicity specification that input is showing where it's saying
up to n instances of whatever.
Yes.
Yeah.
And in this case,
Jose proposed that case would delete 3, and I endorse that.
I think that's fine.
I think it's the most stable because otherwise
Yeah.
you have to analyze.
I agree.
I think it's fine. I think if I then change one of those, yes, I think it's fine.
Okay, that's what we'll go with.
Okay.
I think that's actually what we have currently implemented.
Okay, let's have a very, very quick look at this. And I really want to see the XML versions of this kind of thing. But this is the first special purpose tria. Still not looking very good.
Yeah. So the first point is basically that the labels being the full file paths get very crowded very quickly.
Well, I think this is the wrong way around. Anyway, I think this tree should be left. You know, these trees should be arranged so that they are not like this. I think nobody wants a file system thing this way. It's amusing, but it's not what you want. You want the tree to by default go left to right, don't you?
Certainly the precedent with
If you have a prototype, you could see what that looks like. With tree layout goes to left.
Why is this prototype build not coming to life? Because it takes forever to launch DocuTools in the prototype. Not.
And do tree layout goes to left.
In
That,
this.
that's certainly not the world's most impressive layout.
Bluff. This is horrifying.
Did
So now if I say
is
unlabeled,
this, and this is, oh, you just have a very long lead-in. Okay.
this is funky. What's that 7? What's that doing there?
When you have more than, I think, 10 nodes.
But that's a really ugly thing. It's never been designed, has it? Has that been designed?
No.
That's really bad, if I might say so. And
So
also,
it's
why are there
illustrating
no
it has a
tree layout?
special edge to it.
Why is tree layout arrow left not an option for unlabeled tree?
Options aren't implemented for unlabeled tree yet.
Okay. Look, listen, wait a minute. That bracket 7 thing, that needs design.
Okay.
But also, is it intentional that the edge pointing to it is different?
It looks like a bug.
And I think we'd want them synced up a little better.
But the edge, or that, but I mean, we also got to have an appearance here. And this right now is just a labeled node with a weird, angle bracket 7. Those angle brackets are from like terminals,
Well,
34 years
there's
ago.
also no way to style this. Because
technically, they're not, right? I mean, that's
No, those
actually
are
a named
terminals.
character called Skeleton.
Yes, okay, fair enough. But they are a
There'd be-
modernization of what happened on terminals. Okay, so what were you saying?
There need to be 2 cases for the unlabeled and labeled. One might need to look a little bit different for the unlabeled case.
Yes. Hey, did you have any chance to go through the recoloring of those things? Can we look at that before we end this meeting?
Yeah, let me.
Do you want to share, or is it?
I could send it.
Okay, then we have to wrap here.
This is might be rough. Didn't have Ian's expert hands look at it first, so he's been very helpful to this whole process of understanding.
Let me just pull it into
Maybe the old, yep.
that.
So there, on the right, there's sort of 2 kind of cases. There's the sort of darker, just has a black edge, one's darker and one's lighter around the labeled leaves.
Well, if it's implementable, I mean, I would say that this somewhat lighter one is better.
Okay.
I think that the unlabeled ones are a bit too weighty compared to the labeled ones.
Here.
I don't know. Yeah.
Yeah. Yes, they probably are. But that's a question of whether Ian is able to implement I mean, we could try going a little bit lighter with these nodes.
Okay.
Which would probably be okay here. Can you try that? Just try one iteration of going a little lighter.
Yeah. If you want, I could share.
Yeah. Ready?
Yep.
You could do this with that technology. It would be quite easy. But
Yeah, it's yeah.
okay, anyway.
There was Ian had helped make that notebook, helped make this notebook, and it does have some of that stuff in there. But I think
Okay.
just
Okay. Anyway, I think that looks quite nice, what you've got there. Now let's see if we apply that over to the
that's at 100%.
So wait a minute, I should be looking at the top one over on the right, is that correct?
Yeah.
I think that looks pretty decent. Christopher, what do you think in terms of the relative weighting, or other people, relative weighting of the labeled and unlabeled nodes? They're sort of okay, I think.
I could also export it real quick and you could look at it on your screen.
That doesn't matter. It's going to look
Okay.
the same. It's just bits. Other people's comments here.
Fine to
I
me.
Well,
I mean,
it
you
may
know,
be a little
I still
heavy
think
for
it's weird to
pure.
fill them, but
I'm sorry, what?
I said it looks fine to me, except I wouldn't have filled the nodes. But
Yeah, I mean, would it be possible to see what the current stuff looks like with normal trees?
Yeah, here, send this to me. Here, just unshare.
Okay, yep.
the for some reason the rectangle around the 2 doesn't look quite right. Maybe the size isn't quite matched right now, but something's bothering me about the 2.
Yeah, the scales might be a little bit off in my mock.
I mean, other than that, looks pretty good to me.
Okay, the issue is going to be in an ordinary tree. Okay, so let's say I just say random tree of 30. See, I think that's going to look bad if we thicken up all of those. Can we easily do that? Can we thicken up all those borders?
yeah, do tree element style. All goes to edge form. Then
Billy, what is the edge form? What's the RGB value or something?
486648.
What the hell's that?
The RGB.
He's giving you hex.
Oh,
So
yeah.
RGB
Oh, right.
color
Sorry.
of
Yep,
string.
yep.
What is it? What do we call it? RGB color.
RGB color and then the string.
Chat.
That's not too bad. It's better than I expected. Looks pretty good to me. I like it. Let's go with it. Now, the only question is for a labeled tree, should we just have these be empty boxes? And I think the answer may be yes. That may be just fine. Perhaps that's the best way to do it.
Okay.
And then filled for the unlabeled tree, presumably. Let's see if you can send us out email. Go ahead.
No, I was just saying I agree with that. I think, having a bunch of empty squares everywhere seems a bit silly. So I like the solid there. But if
Fine.
you have there having, nothing, seeing nothingness, it's like, oh, that one doesn't have a label. That makes sense.
Right. You know what the big difference is? Because in the case of unlabeled tree, there may be very big ones. Right. So if I say, oops, I need to go over here for the unlabeled tree. Wait a minute, how do I get the new styling? Ian, how do I get the new styling?
The code is in the agenda notebook.
Oh, I see. Can I just run this? No, but it isn't working here. Oh, because I don't have
Well,
unlabeled.
yeah. So just go to the example and make that 100, right?
This example here.
Yeah,
Yep.
right. Just
Evaluate options 1 in place. What? Oh, this needs to be in a prototype. Sorry.
This code here in the prototype build. Okay, now I go this to this. Okay. Yeah, that's much better. We don't want some crazy thing with. What about the aspect ratio of this creature? Is that right, do we think? This looks much better. I mean, the concept of this being a.
You could specify aspect ratio.
Well, I know I could specify it, but I mean, what do we think is the right aspect ratio? What's determining the aspect ratio right now?
Default graph aspect ratio.
Okay, which is what, Charles?
well, assuming it's sticking to graphics, right? That's 1 over is. Or is
I
that
know, but
only
it's
plot?
obviously not. It's obviously not.
Mhm.
So the question for Charles is, what is the aspect ratio of a graph by default? Because it's not. It does something intelligent.
But I need to think about it. I don't remember what we did at the time.
I remember talking to you about it at length. We came up with something
Right.
kind of clever.
Right. The default is automatic, but that's not what automatic means in visualization functions, right? Because in visualization functions, it means take it from the plot range, right? Deduce, make the aspect ratio match the ratios of the
Yeah,
range.
right, exactly. Which is not what this does. This is doing something based on, I mean, and so we haven't even thought about what the aspect ratio for this. So this thing here, basically you're saying, I want to be able to take this. Is that a graphics? You've just made this into a graphics. So we can just say graphics, aspect ratio, arrow 1. What the heck? Is this not a graphics?
No, that's a bug in the prototype build.
Okay.
It's a tree.
Okay. So if I say tree, I think that looks somewhat better than this. I don't know. I think these shallower aspect ratios look better. Comments from people. Look, for a tree, there is clearly a. Okay, give me a sense of this. There's the tree depth, which is the number of levels, right?
Yep.
And there is, what is the tree breadth? That is the number of, what determines that? What determines how wide these things are? Is it the
maximum number of, it's like the maximum length of a level?
Is it just of one level? I mean, if you, but does it reuse the slots? In a vertical slice.
It appears to reuse the slots. You can see some places where it does, I think.
Okay. So Ian, can you say that? It's reusing the slots?
For the embedding?
Yes.
I'm not sure.
Well, who knows that?
What do you mean by resume the slot?
What I mean is that, I mean, it obviously is, right? Because this thing, this node here, okay, a given node, what am I trying to say? If you look at the horizontal position of a node, yeah, it reuses the particular horizontal position many times.
You can see an example where it definitely does, sort of to the right a bit.
Okay.
There's to the right of where your mouse is.
That
like
one
fan,
there. That one there.
No, that one there, and then there's an example to the right of that that's even more extreme.
Okay, where the fan overlaps the other fan.
Yes.
Right. Okay. So, well, Okay, so the question really is, there's a certain maximum width, which is not completely obvious to me what determines it. I don't think it's the number of distinct things on a given level. I think it's more subtle than that.
I think that depends on the embedding.
Look, we've got a particular embedding. I'm asking for this default embedding. We've got a certain width, which is, I mean, the nodes are equally spaced in x coordinates in whatever that choice of embedding is. And they are also equally spaced in y coordinates. So the question is, given, you know, maximum x extent and maximum y extent, aka depth, what should the aspect ratio be? Did you get the question? You understand what's that?
So you want to determine the aspect ratio based on the depth and encode the width of the graph, right?
We know the width of the graph, Charles. The width of the graph in x units, we know. And the depth, the height of the graph in y units, we know. We've just got two numbers, and we've got to determine, given those two numbers, what shape do we want the graph to be? So here's an example of what we could do. We could say we want the opening angle of the trees to be x. Right? We want the minimum opening angle. There's always going to be, given the x positions and y positions, the minimum opening angle is that arctangent of, you know, min delta y over min delta x. Is that correct? Do you see what I'm saying?
Yes, sure. But what I was just essentially thinking is, you know, what tree is using. That you're just using a layered layout, which is more based on an optimization problem. So we essentially pose it as a, you know, linear constraint optimization, where we don't actually take into account those additional informations.
But I know, but the aspect ratio is determined after the fact, isn't it?
No, actually, if I remember correctly, so the fact of, I mean, the way we adjust the coordinate, right? We essentially are, when we solve the optimization problem, we readjust the coordinates so that we get the appropriate aspect ratio automatically without changing it.
I see. Well, what is the appropriate aspect ratio? You don't know at this point.
I don't remember the method of technique.
Right. We need to look at this because I don't think these trees, I think these trees should be flatter. I think. Anybody else got an opinion about that?
But if I mean,
wait. I just want to know, do people think that tree looks good or do they think this tree looks better?
I mean,
Or
my
do
initial
you have
impression
any
is the
opinion?
first one.
The first one.
The first one.
Yeah, I
first
think
one.
the first.
Well, okay, that's what we have right now.
I have the impression that there is some sort of a square grid behind this, and we tend to believe that the squares should be square, not rectangles.
Fine. Well, if we think the first one looks better anyway, then we don't have a problem. I mean, that's the default. That's what we have right now. So even if it's shrouded in antiquity and mystery, why it is that way, we're good. That doesn't look bad. Now, by the way, just notice that if we tried to do this with labels, we'd be absolutely dead in the water. That's pretty nice looking. Do people agree? I mean,
yep.
I mean, we optimized the default layout to work nicely. So it went to several tests. So
yeah. Well, it's good. All right. So we can just declare victory there. So this means, I mean, how big can I go here, do you think? If I go 1,000 node random tree, what's taking time? Is it the layout or is it the, oh, that's quite lovely.
I think random tree is slower than the layout.
Trying to get the measure correct.
Mm-hmm.
But I think it's lovely. Looks great. All right, we declare victory. Okay, anything else we need to figure out? Really late for other stuff. Nope.
I think that was the main slate of things that we're going to look at today.
Excellent. Okay, thanks all.